Hello and welcome back to e-CBSE online classes. Today we are going to start a new module called probability for mathematics class 10th. The specific topic of today's video is empirical probability. This is part A of the video series in this module. Okay, before we get into the details of the module, let us give some food for thought. Let's say I give you a scenario. You are offered a lucky draw coupon for $100 and the prize money if you win is $1 million. And the total number of coupons being sold are 100,000. So if you are in this situation, will you buy the ticket and why? Let me give another situation. There are 50 students in your class. Without even looking at the data of the dates of birth, your teacher makes a bet with you that at least 2 students in the class have the same birthday. Will you take that bet and why? So how will you decide in such situations? So probably you must have already guessed it. So the knowledge of probability will help you to take certain decisions based on the possibility of your favorable outcomes. Okay, now let's look at some statements here. What are the chances that the newborn is a girl? Most probably it will rain today. It is highly unlikely that COVID-19 pandemic ends in 2020. I am 100% sure that the sun rises in the east today. I doubt if I would pass my mathematics exam. There is 50-50 chance that India will win the toss. Notice the keywords here. Chances, most probably, highly unlikely, 100% sure, doubt, 50-50 chance. What are common in all of these keywords? See, there is an element of uncertainty, right? The branch of mathematics that deals with this element of uncertainty purely because of chance and guides us to take a guided and intelligent decisions in such situations is called probability. Okay, some definitions before we proceed further. An experiment is a process of measurement or observation. So when I say experiment, you must be immediately thinking that I'm talking about some laboratory here. But it is not necessary that all the experiments takes place only in the laboratory setup. You can do it in your home also. For example, tossing a coin or rolling a dice can be called as experiments. A trial is a single performance of an experiment. For example, rolling the dice once is called a trial. The result of a trial is called the outcome or sample point. Okay. For example, if tossing a coin is an experiment, head or tail are called outcomes. A specific outcome is called an event. For example, if you are rolling 2 dice, the total of the 2 dice can be anywhere from 2 to 12, correct? So if I want to ask what is the chance that total of 2 dice being 7, that's a specific event that I'm talking about. Okay, now let's take a quick experiment here. Let's call that experiment number 1. I give you a 1 rupee coin and ask you to toss it 10 times and note how many times you get head. Okay, I make a table here. In the first column, you'll note the number of heads. In the second column, you'll note number of tails that you'll get. And in the third and fourth columns, you do some calculations with it. Okay. So when I did that experiment with on myself, I got 6 heads and 4 tails. So the ratio of total number of heads to the total number of tosses is 6 by 10 because I did 10 total tosses, which is my denominator. And out of that, 6 of the outcomes have come out to be heads. So the numerator is 6. 6 by 10 is 0.6. A similar calculation for number of tails is 4 by 10. It is 0.4. And then I repeated that experiment 10 more times and I got 3 more heads and 7 more tails. So what are my total number of heads out of the 20 experiments? It is 6 plus 3, which is 9. So the ratio of total number of heads to total number of tosses is 9 by 20. It is 0.45. Similar calculation for the number of tails is 0.55. And I repeated the experiment one more time and I got 4 more heads and 6 more tails. So the total number of heads divided by total tosses is 13 by 30, which is 0.433. Similar calculation for number of tails is about 0.566. Okay, couple of points that you need to note from this table is the in any of these rows, the sum of the values in column 3 and column 4 are coming out to be 1. And another point is, if you repeat this experiment sufficiently large number of times, say 1000 times or 10,000 number of times, the ratio of total number of heads to total tosses will come out approximately equal to 0.5. Okay. Now let's do the second experiment. You have a dice and I ask you to toss it 100 times and fill the following table. When you roll a dice, what are the possible outcomes? 1, 2, 3, 4, 5, 6, correct? So let us note how many number of times that I got 1 as the outcome and 2 as the outcome and so on. So when I did my experiment, I got 13 times 1 and I got 2 15 times, 3 17 times, 4 20 times, 5 16 times, 6 19 times. Okay, when I ask you to take a ratio of number of times that 1 has showed up divided by total number of times the die is thrown, how will you calculate that? Okay, number of times 1 is shown up is 13, right? Total number of times I have rolled the dice is 100. So 13 by 100 is 0.13. So what are we doing? I mean, what are these ratios that we have been calculating in experiment number 1 and experiment number 2? So those are called empirical probabilities. The definition of empirical probability is, let's say there are n number of total trials and the empirical probability P of E for an event E happening is given by the ratio of number of trials in which the event E has happened to the total number of trials. Okay, this is what we have been calculating in the previous two experiments. So formally the equation goes like this: P of E is equal to number of trials in which the event E has happened divided by the total number of trials that has conducted. Okay, so this is the definition of empirical probability that we have built. Stay tuned. In the next video, we are going to talk about how to arrive at theoretical probability in certain situations. I hope you like this video. Please like, share, comment and subscribe to our channel e-CBSE online classes and follow us on Facebook. Thank you for joining.